Okay, so this is going to help us review a little bit of Chapter 4 and focus on what we need to know for Wednesday's quiz. I haven't made it yet, so it could have some. I'll make it a majority of it multiple choice for sure, but there might be some fill in. All right, so let me try to, zoom in on this. Hopefully you can see it. I will put this on Google Classroom as well. So this first one, so 4-1, this is one of the ones that will be on the quiz Wednesday. So the 4 types of tissue found in the body: epithelial. So epithelial tissue lines internal and external surfaces. Connective tissue is like all the filler, fills internal spaces, provides structural support, stores energy. Muscle contracts to produce movement, so it gets shorter. And neural conducts electrical impulses, carries information, like the nervous system. Okay, and remember when I was suggesting ways to remember those things, 3 of them are pretty easy to remember: epithelial line surfaces, muscle can contract, and neural can conduct electrical impulses for sending signals. And then connective is all the other stuff, the filler. So that's kind of a good one to remember last. Kind of like when we talked about those biomolecule groups and leaving proteins to last because they have so many functions. Kind of a similar idea here. Okay, so that's 4-1. That's the first success criteria. And then 4-2, 4-3 grouped together because it's all about epithelial tissues. So I tried to make some note of characteristic features. I should make some notes of probably added locations in the body more, maybe. So maybe I'll write that in on this video. But first of all, we have the 3 simples, meaning the 3 types of tissue that are only one layer of cells. That's what simple means, right? So we can have simple squamous, which would be one layer of flattened cells. As far as characteristics go, I just kind of underlined that. One layer, flattened cells. Simple cuboidal, one layer of cubed cells. Simple columnar, one layer of column cells. But I did put key characteristic here, microvilli for absorption. That's why we would find it in the digestive tract. So those are our 3 simples. And then we have multi-layer, or what appears to be multi-layer. We have stratified squamous. So stratified means many layers of flattened cells. And that makes them good for protection, by the way. And so an example of stratified squamous would be your skin. We have transitional, which looks like many layers of cubed cells, almost looks like stratified cuboidal, or it could look like stratified columnar, depending on if it's stretched or not. And that's the key characteristic of transitional, is that it can stretch. And one way to identify it from the other ones, if it does look like multiple layers of column-shaped cells, It has no surface feature. Any of the other column-shaped tissues have surface features, like pseudostratified ciliated columnar, for example. It appears to be stratified. It's not really. Has nuclei at different levels. That's how you can tell it apart from simple columnar. Okay, so if I looked at simple columnar, they would be column-shaped, but the nuclei, the dark spots in the cells, would be at the same level, whereas with pseudostratified ciliated, if I have all these column-shaped cells and tissues, the nuclei are like all over the place. Oops, shouldn't have done 2 in there. You get the idea. And you would see a little surface feature that would actually be cilia, which makes them good sweepers, which makes them good for respiratory tract. I think on this video, I'm just going to go through the 3 that you need to know for Wednesday, because otherwise we'll be here for a while. And then I'll make a separate video for the other ones. I'm about to go over those. So our concept map for connective tissues looks something like this. We've done this before. I think even the day we did it, we practiced kind of doing it on our own. So make sure you have that. Looks kind of light here, but we've got connective tissues in general. There are 3 main groups. We have the connective tissue proper over here. We have fluid in the middle. We have supporting over here on the right. So supporting, that's going to be tough. That would be bone and cartilage. Okay. Fluid, not tough. Can actually flow, can move. I guess I do have to show you the second page a little bit because there's one more question relating to 4.4. But fluid would just be like blood and lymph. And then we got to remember that the connective tissue proper, CTP, has subgroups within it. We can have loose connective tissue, and we can have dense connective tissue. So if you think about tendons and ligaments, students get those mixed up a lot. You don't necessarily need to know the difference yet. But tendons are connecting muscles and bones, and ligaments connect bones and bones. But they go together under dense connective tissue, where loose connective tissue is more like fat. Adipose tissue is another name for fat. And areolar tissue, which is very similar. So okay. Ligaments here. So we can have ligaments, and we can have tendons. Okay, so the last question that we're going to cover on this video, I got to go to my second page. So here it is. All right. And if you're trying to answer those last 3, I will put this on Google Classroom. But for the quiz, the last one we have to do, this is still with 4.4, like the last section. It's talking about the three different types of connective tissue in terms of the three main components of connective tissue. That is the ground substance. What is that like? That's kind of like the surrounding substance. The protein fibers and the types of cells that we have. Sometimes it's just a wide variety of cells. Like in the connective tissue proper, it says various cells and fibers, okay? Kind of a diverse, not specific. So these have kind of a syrupy ground substance, which means like syrup. We have fluid, which, as you can guess, the ground substance is very watery. This does have distinctive cells, like we have distinctive blood cells and white blood cells. Dissolved proteins, so we don't really have those protein fibers, which if we did, it would make it kind of hard for it to flow, because usually the protein fibers add some strength and stability. And then supporting very dense ground substance, closely packed fibers, making it tough, making it supportive. And it does have distinctive cells. Later on, when we look at bone and cartilage, you should be able to see those and identify those under a microscope pretty easy. But so it's those questions, the front side and that one on the back, that you need to have mastered for Wednesday.